Hello everyone, welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. We already discussed about the rational numbers and their properties, right? Like commutative, closure, associative, distributive properties. Now today we are going to discuss about the decimal form of a rational number. Okay, na? Let us see that. So we have discussed that every rational number is in the form of p by q, where p comma q belongs to integers and q does not equals to 0 is the condition. Am I right? That means positive rational numbers, negative rational numbers also we have taken. Am I right? So example 3 by 5. 3 by 5 or 5 by 2, whatever. These are all in the form of p by q. We can express these rational numbers into decimal form. For example, the denominator is always becomes a divisor and the numerator is taken as dividend. Now 2 table 5 won't come, but 2 2s are 4, remainder 1. Am I right? Now we are leaving the remainder 1. We have to complete the division up to get the remainder 0. So for that I am taking the help of point and 0 I have taken. Okay, so 2 table in 10 5 times 0, so nothing but 2.5. So that means 5 by 2 decimal form is 2.5. Same way, we are taking 3 by 5 dividend, the denominator always the divisor and the numerator 3 becomes dividend. 5 table 3 is less than 5, 5 zeros are 0, remainder 3. It is not sufficient here. Put point and take 0. 5 table 36 times. That means 0.6. So 3 by 5 value is nothing but 0.6. That means if you take any rational number, we can express this rational number in the form of decimal. Right. Let me take one more example. That is 3 by 7. 3 by 7. So let me do this. So 7 table here 3. 7 becomes the divisor. 3 dividend. Again 3 is less than 7. 7 zeros are 0. Remainder 3. Put point, take 0. 7 table 30 won't come, but nearer value 7 4s 28. 30 minus 28 is 2. 2 is less than 7, we already keep 1 point now. For every step, I can take 1 0 until I get the answer. Next, 7 table, 7 2s are 14, remainder 6, again 0, 7 8s are 56, remainder 4, again 0, 7 5s 35, remainder 5, again 0, 7 7s are 49, 1, 7 1s are 7, 3, again 7 4s 28. So 3 means again this was 3, remainder 3 means again it is continuing, right? So that means 4 2 8 5 7 1, again 4 2 8 5 7 1, 4 2 8 5 7 1. You will get the quotient like that only. So while you are observing first 2 examples and third example, there is a difference between them. Here the decimal value is terminated. That means the value is stopped there. But it is not stopping, it is continuing like that. Okay, na? That means from this we have to say that every rational number, that means if you take any rational number, the rational number is terminating decimal or repeating decimal. Only 2 forms are there. Okay, na? You are getting terminating decimals, but here repeating, repeating decimal, not terminating, repeating decimal. So simply for this we have to say that the decimal form of a rational number, is terminating decimal or non-terminating. It is not terminating but repeating. Non-terminating repeating decimal. Okay, na? So we have discussed the properties of rational number and the decimal form of a rational number. How the decimal form of a rational number? Terminating decimal, or it is non-terminating repeating decimal. Okay, na? Yeah. But if you take some of the numbers not repeating, so we can call that as irrational numbers. Let us discuss about the irrational numbers now. So irrational numbers. Actually, irrational numbers are nothing but the numbers cannot be written in the form of P by Q. The numbers can be written in the form of P by Q are called rational, cannot be written in the form of P by Q are called irrational numbers. Okay, na? So like we can take three different type of irrational numbers are there. So mostly example 1 here, root 2, root 3, root 5, root 6 and so on like this. Okay, na? So these are all examples of irrational numbers. Square root of 2, square root of 3, or cube root of 2, cube root of 3, cube root of 4. These are also examples of irrational numbers. Okay, na? Right. So numbers cannot be written in the form of P by Q form are called irrational numbers, and examples are root 2, root 3 like this. Okay, na? But here decimal form of rational numbers you have discussed that terminating decimal or non-terminating repeating decimal. But what is the decimal form of irrational numbers? Decimal form of irrationals. They are non-terminating, non-repeating. They won't end. That means non-terminating decimals. Non-terminating, and there is no repetition also. Non-terminating, non-repeating decimals are called irrational numbers. Okay, na? Terminating or repeating decimals are called rational. Non-terminating, non-repeating are called irrational numbers. Examples are these. Okay, na? Yeah. Let us go to the next concept. Okay. Now, let us take properties of irrationals. Properties of irrational numbers. For example, if you take one number as rational number, second number is irrational number, that means while you are taking two numbers, one is rational, another one is irrational, between them if you use any one of the arithmetical operation, plus, minus, into, division, among the four, any one of them you can use, the answer is definitely irrational number. The answer is definitely irrational number. Okay, na? Right. From this we can say that if you are taking one rational and one irrational number, rational numbers are represented with letter Q, right? Irrational numbers are represented with the letter Q dash. I am taking one of the number is rational, one of the number is irrational. So from this, sum of first property, sum of a rational number and irrational number. Sum of a rational and irrational is irrational. Okay? Sum of a rational number and irrational number is a irrational. Example, 2 is a rational number plus root 3 is a irrational number. So 2 plus root 3 value is 2 plus root 3 itself, because we cannot add these two terms because both are unlike terms. If both are rational numbers, we can add. Both are irrational numbers, we can add. That is also depends on its order, okay? So we cannot add 2 plus root 3 value is 2 plus root 3 itself. So it becomes a irrational. It becomes a irrational. Belongs to Q dash. Q dash means irrational numbers. Okay, no? So sum of a rational and irrational number is irrational. And the difference of a rational, again, difference of a rational and irrational number is also irrational. Okay, na? Sum of a rational number and irrational number is irrational. Difference of a rational and irrational also irrational number. So example, root 3 minus 5, 7 plus root 7, 7 minus root 7, 13 minus 4 root 3, etc. These are all irrational numbers. Here 5 is rational, root 3 is irrational. Their difference is irrational. 7 is rational, root 7 is irrational. Their difference is irrational. Same like 13 is rational, 4 root 3 is irrational. Their difference also a irrational number. Okay, na? Sum of a rational and irrational numbers becomes irrational. Same way, difference of a rational number and irrational number becomes also irrational number. Next, product. So product of a rational and irrational numbers is irrational. I told you already. So if you take a rational number and irrational number, apply any arithmetic operation between them, they must be irrational numbers. Okay, na? So here also irrational numbers. 2 is a rational, root 3 is a irrational, 2 root 3 is irrational. Okay, right. Same like quotient of rational and irrational number is irrational. Clear until then? Yeah. So let us go to the next concept. So P by Q form numbers are rational that we can write in the form of P by Q, and their decimal form is terminating decimal or non-terminating repeating decimal. Irrational numbers means the numbers cannot be written in the form of P by Q are called irrationals. The decimal form of a irrational number is non-terminating, non-repeating decimal. Okay, na? So let us see some example or some problems based on this concept. After the problems, let us go to the remaining concepts. Okay, yeah. Now, conceptual based questions. So the rational number does not have reciprocal. The rational number does not have reciprocal. Do we discuss about reciprocal, right? Additive inverse, multiplicative inverse. Multiplicative inverse only we called reciprocal. Okay, let us revise once again. So additive inverse and multiplicative inverse. Multiplicative inverse is also called reciprocal. Multiplicative inverse is also called reciprocal. Okay? Yeah. So additive inverse means if you take any number a by b, any rational number a by b, add with another rational number c by d, then the answer becomes 0, where a by b is a additive inverse of c by d and c by d is a additive inverse of a by b. Let us take one example here. 2 by 3 plus minus 2 by 3 equals to 0. For 2 by 3, we have only one additive inverse. We don't have more than one additive inverse for every number. Every number having only one and only one additive inverse. We cannot write multiplicative inverse. Okay. So that means every positive integer or every positive rational number, there exists a negative rational number. Every positive rational number, there exists a negative rational number whose sum becomes 0, then that condition or that property is called additive inverse. Okay, na? So, additive inverse of 2 by 3 is minus additive inverse. That means its negative becomes its additive inverse. Same way, 0 additive inverse is 0 itself, minus 0, because 0 is neither positive nor negative. If you are taking 0, we cannot say that minus 0, because 0 cannot be minus. It is not negative, neither negative nor positive. 0 additive inverse is 0 only. Additive inverse of 1, minus 1, both are different. Additive inverse of 2, minus 2. Additive inverse of 6 by 7, minus 6 by 7. Additive inverse of minus 11 by 10, plus 11 by 10. Okay, na? So, for every positive rational number, there exists a negative rational number whose sum becomes 0, then we can call the both of the rational numbers are additive inverse of each other. Okay, right. Now, let us go to the multiplicative inverse. Multiplicative inverse means when you multiply two rational numbers, answer is 1. When you multiply two rational numbers, the answer is 1. Otherwise, product is 1. We can say that the two rational numbers are multiplicative inverse of each other. The two rational numbers are called multiplicative inverse of each other. So, for example, 2 by 3. When 2 by 3 becomes 1, multiply with some other 3 by 2 only possible. Then 2 3s are 6, 2 3s are 6, 6 6 cancel one time. So, while you are observing here 2 by 3, 3 by 2, the position of the numerator and denominator only changes. Okay, na? So, here we have to identify 2 by 3 multiplicative inverse is 3 by 2. Same way, 5 by 6 multiplicative inverse 6 by 5. Minus 1 by 3 multiplicative inverse minus 3 by 1. Your symbol is not affected. Only the numerator denominator positions will be affected. Here symbol will be affected. There is no change here. Only symbol changes. Positive means negative will come. But here, ulta we have to take it. Means numerator and denominator positions will be changes. Okay now? Same way 0. What is the 0 reciprocal? Reciprocal of 0. 1 by 0. 0 means 0 by 1, right? We have to write 0 means 0 by 1. So 0 by 1 reciprocal is 1 by 0 is not defined. So from this we have to say that the rational number which does not have reciprocal is 0. Okay, let us take here 1. What is the reciprocal of 1? 1 means 1 by 1. Its reciprocal also 1 by 1 itself. Reciprocal of 1 is itself. Reciprocal of minus 1 is itself. Reciprocal of 0 is not defined. Okay, na? So according to this, our solution is the rational number that does not have any reciprocal is 0. Okay, children, just listen. So we are discussing about the denominator of a rational number. If a rational number containing the denominator only 2's or only 5's and 2 and 5 combinations, the rational number is definitely terminating decimal. The rational number is definitely terminating decimal. Let us see one example here. 15 by 8 while you are observing here. Here this is 8 is not a 2, not 5 but not 2 into 5. But even though I am saying that it is terminating decimal, because 8 is nothing but combination of only 2's. 2 into 2 into 2. Am I right? 2 2's are 4, 4 2's are 8. That means there is only presentation of 2 is here. So it is definitely terminating decimal. Let us see through an example. So 8 table 8 1s are 8. Remainder 7, put point and take 0. Now 8 table 8 8s are 64. 6. Again, if you take 1 point, another 0 you can take. 8 7s are 56. Remainder 4. Again, one more 0. 8 5s are 40. So it is stopped at 1.875. It is not repeating like 5555 like that, right? So we can say that it is terminating decimal because its denominator, while you are writing the denominator as product of prime numbers, 2 into 2 into like 5 into 5 into like that, if the denominator containing only 2's like 2 into 2 into 2, like 2 into 2 into or only 5's or 2 and 5 combinations, nothing else, it should not get any other number in that, then we can say that the number will be the terminating decimal. Okay, na? Now let us take one more example here. 15 by let us take 15 by 16. 16. Can you express 16 as product of prime numbers? Yes, it is 2 into 2 into 2 into 2. 2 2 is 4, 4 2 is 8, 8 2 is 16. Yes, it is terminating decimal. Okay. Next, 32 by 5. The denominator is only 5. Yes, it is terminating decimal. 32 by 7. 7 is a prime number and there is no presenting of 2 and 5 here. Only 7 is there. So it is not a terminating. This is non-terminating repeating. Non-terminating repeating decimal. Okay. Now I am taking 5 by 14. Is it terminating decimal or non-terminating repeating decimal? 14 I can write 2 into 7. 2 7s are 14, but there is a presence of 2. According to definition, I said that only 2 must be there. There is no another number. But here 7 also presenting. 7 is cancelled in 5 table? No. 7 is not cancelled. 7 is remaining like that. So it is non-terminating decimal. That means non-terminating repeating decimal. Clear? So we discussed about the rational number, irrational numbers properties, as well as additive inverse, multiplicative inverse, and then between numbers, the denominator of a rational number is in the form of 2 and 5 and 2 into 5. So 2, only 5 or 2 and 5. Then we can say that they are terminating decimals or else they are non-terminating repeating decimals. Okay now? Right. So until then, 6 problems over. So 7th problem is the fraction is in the simplest form after cancellation. Simplest form of a rational number is the denominator. While you are observing the denominator having the prime factors, the prime factors containing 2 and 5 are 2 into 5. Then we can say that the fraction number is terminating decimal. You are having that it is terminating decimal. So 7th one answer is terminating decimal. Okay. Let us go to the question number 8. So while you are observing a decimal number in which all digits after the decimal point are repeated. All digits after the decimal point are repeated, it is called mixed recurring decimal, pure recurring decimal, terminating decimal, non-terminating, non-repeating decimal. So it is called pure recurring decimal. It is called pure recurring decimal. Okay na? So let us discuss that also. That means while you are observing the decimal numbers like 0.2356, I am keeping the bar on all 2356. That means after the decimal point, all the numbers are repeating like this. Periodicity is 4 and 4 digits are repeating. 2356 is period. So all of them are repeating. It is called pure recurring decimal. In case if I write like 2.2356, 356 only repeating. But here 2 also is there. 2 is not repeating. Only some of the numbers after the decimal only repeating. So it is called mixed recurring decimal. Pure recurring decimal means after the decimal point, all the digits must be repeated. Pure recurring decimal. But after the decimal point, only some decimals are repeating is called mixed recurring decimal. Okay na? Right. So that's it for today, children. Thank you one and all. Have a nice day.